Alright, so you're driving a 1,200 kilogram car, so I got a mass equal to 1,200 kilograms. You are traveling at a constant speed of 14 meters per second, so I have velocity, initial velocity, 14 meters per second. As you approach the intersection, you slam on the brakes, the car's wheels lock, the tires begin skidding, and the car slides to a halt in a distance of 25 meters. So, change in displacement, 25 meters. Alright, what is the coefficient of kinetic friction between you, your tires, and the road? Alright, they don't give me no forces or nothing here. So, what do we know?
This time we need links group 10-2, Miss Sherry Davis's, to go to the library.
At this time, what do we know? Forces that are acting on it. Force of gravity.
Natural force.
Normal force.
What's the natural force?
Normal force.
I can crack a joke.
Sorry.
Alright, normal force, what else?
Your acceleration. But you'd have to find it. But it's not technically force, is it?
Am I applying a force?
We're at a constant
Force.
Newton's law.
I hit the brakes and I lock this thing up.
We're going to do
Am I applying a force, or is
You're adding the force. Kinda.
kinda?
A negative force.
Okay.
Force of kinetic friction. Why? Am I applying any forces to it? No. I'm moving in this direction. I'm slowing down and I eventually stop. What does that mean? There has got to be a force being applied opposite of my motion that'll slow me down. So there has got to be a net force that is in the negative direction, because we're going to make the right positive and up positive. Okay. I'm trying to find the coefficient of kinetic friction. There we go. Okay.
Is your lens open?
Huh?
Is it working?
Yeah,
Are you sure?
I'm positive.
Okay, just check.
Okay, coefficient of kinetic friction. That's the thing we're looking for. Alright, so what is the formula dealing with kinetic friction? Force of kinetic friction is equal to the coefficient
K.
of kinetic friction times normal force.
Natural force.
I'm trying to find the coefficient. I can find the normal force, but right now where I'm at, I really have enough information to get that force of kinetic friction yet. No, but let's start working on what we can.
We can do the natural force.
Okay, I seen your face. The answer is yes, you do have information where you can. I apologize if I offended you.
Oh, you're okay. I was just gonna do it.
Okay, you go right ahead and you do it.
Do you want to let us in on that one?
Do work for it. What? This is do work for it.
Alright, so we have normal force is equal to an opposite force of gravity, because it's equal in magnitude but it's opposite in direction. So in this case I'm going to find force of gravity, which will equal my mass times gravity, which is equal to, my mass is 1,200 kilograms, times gravity, which is negative 9.81 meters per second squared. I'm going to get me a new calculator.
This time we need links group 10-3, Mr. Bill Daniels group, to go to the library. Links group 10-3, Mr. Bill Daniels group, please go to the library.
11,772 newton, negative 11,772 newton. Normal force is equal to the opposite of force of gravity, so it is equal to 11,772 newtons. Booyah. So I now have normal force. But I still don't have everything I need. I gotta find a way to find this force of kinetic friction. So what you got? Let me hear your thought process. What do you think?
I don't know if this is right, but you know the other day when you said that applied force or whatever, I thought that maybe, just maybe, it would be the mass and then the acceleration of the car. Would it?
Do I have acceleration of the car?
Well, you could find it with change of velocity or change of time.
Yeah, but we don't have time.
I found time too. It's the change of position over change of velocity. I swear if I sat on my couch and cried trying to figure this out because I thought it was due today, and then I texted Brooke and she was like, that's not due. And then I did it wrong.
Okay, you absolutely could be on something. I absolutely know I gotta find acceleration.
Okay.
So I'm going to start dealing with a motion problem here. I'm trying to find this acceleration going backwards. So in this, I have an initial velocity, 14 meters per second. Final velocity, 0 meters per second. I have final position. Let's do a change of position. I think I know what I'm going for. Change of position is 25 meters. And yeah, that's it. This is the formula I'm going to use. Final velocity squared equals initial velocity squared plus 2 times acceleration times the change in position.
I need to remember that.
I think you've said that on both quizzes to me. So I'm going to solve this thing around where I can get acceleration. So velocity final squared minus velocity initial squared is equal to 2 times acceleration and change in position. So acceleration will be equal to
Any sophomore girls basketball team members?
velocity final squared minus velocity initial squared.
All sophomore girls basketball team members, please go to the library.
Divided by 2 times change of position. There we go. Now I'm ready to plug stuff in. Final velocity 0 meters per second minus initial velocity squared, which is 14 meters per second. And that's squared. Divided by 2 times change of position, which is 25 meters. And we'll punch that all on the calculator. And I get acceleration to be negative 3.92 meters per second squared. Any questions on how I did that?
I did it different than I wrote it.
This is why it's not a constant velocity. That's why I'll be really, really careful with jumping to those conclusions like that. But you're okay. It was a good idea. It was a good thought process.
Okay.
So, now I got acceleration. So, I can now find this force of kinetic friction. So, force of kinetic friction is in the x direction. It is actually my net force in the x direction. So,
Why are you getting negative 3.92? Because I'm not getting it.
you do 14 squared?
Oh, I didn't square it.
I didn't need it.
By who?
Sorry.
Yes.
I was starting right now. I was doing so good. And then, I was not feeling it. I don't even. I don't know, I don't know. I have a paper with all my forms.
All right. So we're on that. So we find out that force of kinetic friction is the net force in the x direction. So I can just solve net force equals mass times acceleration. So the net force will be equal to my mass, which is 1,200 kilograms, times that acceleration we just calculated, negative 3.92 meters per second squared. Does that negative matter?
No, because it's magnitude.
Yes. Yes, it matters.
Yes, it matters.
That was magnitude.
Positive direction, negative direction. All right. Find out that it's 47.04. So 4,700, negative 4,704 newtons. That's the force. So
What they want.
it's not what they want. So, but do I have all the pieces of information I need to get that now? Absolutely, because I got this force of kinetic friction down. So, I'm going to do this one in purple. Force.
Because it's important.
That's right. Force of kinetic friction equals kinetic friction coefficient times normal force. So, kinetic coefficient equals normal force divided by force of kinetic friction, which will be equal to the normal force. Calculated, it's 11,772 newtons divided by force of kinetic friction, which is the net force in the x direction, which is 4,704 newtons. I have that negative there. Does the negative matter? No. Why does it not matter? It's a big coefficient. We're never gonna-
Wouldn't it be backwards?
Yeah, you got that.
Do the reciprocal.
Good job, guys.
It was Liam, not.
Good job, Liam.
Nice.
This is why you're supposed to watch it. Okay.
Well, I'm watching. I told you where you messed up. I don't know what else you wanted.
Hey, I gave you a shout out. So hush up.
Liam.
Just now, shout out to you, Liam, right here on
Say his
YouTube.
Facebook name so everybody can know.
I ain't doing that.
Yeah, don't do that.
All right, kinetic coefficient equals friction, force of kinetic friction, which is 4,704 newtons. That negative doesn't matter because where it's going to be the coefficient just needs to be a positive number divided by 11,772 newtons. And you're going to do that in the calculator. To find 0.3996.
What's the unit?
There's not units
Why?
because the newtons cancel.
Oh, fine.
What would be your question?
That's our answer.
That is the answer for 73.
Oh. That on the neck. Oh, that was okay.
It's even what the book got. So no questions. Everybody good?
Yeah. Now that I know what I'm doing.